by n matrix A of rank R. Okay. What's our definition of rank? Our current definition of rank is number of pivots. Okay. First of all, how are these numbers related? Can you tell me a relation between R and M? If I have M rows in the matrix and R pivots, then I certainly know, always, what relation do I know between R and M? R is less or equal, right? Because I've got M rows, I can't have more than M pivots. I might have M and I might have fewer. Also, I've got N columns. So what's the relation between R and N? It's the same, less or equal, because a column can't have more than one pivot, so I can't have more than n pivots altogether. Okay. Okay. So I have an m by n matrix of rank R, and I always know R less than or equal m, R less or equal n. Now, I'm especially interested in the case of full rank, when the rank R is as big as it can be. Well, I guess I've got two separate possibilities here, depending on what these numbers m and n are. So let me talk about the case of full column rank. And by that I means R equal n. And I want to ask you, what does that imply about our solutions? What does that tell us about the null space? What does that tell us about the complete solution? Okay, so what does that mean? So I want to ask you, well, okay, if the rank is n, what does that mean? That means there's a pivot in every column. So how many pivot variables are there? N. All the columns have pivots in this case. So how many free variables are there? None at all. So no free variables. R equal n. No free variables. So what does that tell us about what's going to happen then in our little algorithms? What will be in the null space? The null space of A has got what in it? Only the zero vector. There are no free variables to give other values to. So the null space is only the zero vector. And what about our solution to AX equal B? Solution to AX equal B. What's the story on that one? So now that's coming from today's lecture. The solution X is, what's the complete solution? It's just X particular, right? If there is an X, if there is a solution. It's X equal X particular. There's nothing, there's just one solution, if there's one at all. So it's unique solution. Unique means only one. Unique solution if it exists. If it exists. In other words, I would say, let me put it a different way, there are either 0 or 1 solutions. This is all, in this case, R equal n. So because many applications in reality, the columns will be what I'll later call independent, and we'll have nothing to look for in the null space, and we'll only have particular solutions. Okay. Everybody see that possibility? But I need an example, right? So let me create an example. What sort of a matrix, what's the shape of a matrix that has